Alright, so now we've got question 2. This is really easy. Calculate the probability to find a particle in the following regions. It's a one-dimensional box. So a one-dimensional box, if the box, so they're even giving you the length, 10 nanometers, but you already know that a one-dimensional box, the wave function is 2 over a, or the length in the x direction, sine nx pi x over a. I think that looks right. But when you're calculating probabilities, what you're supposed to do is the probability from will equal the first distance in the x1 up to x2. You square the wave function dx. So I need to square this. So if you square this, so the wave function squared will be 2 over a sine squared nx pi x over a. So that looks correct in its ground state. So if you're in your ground state, the nx has to be equal to 1, right? You already know that a, you can just leave this in and fill it in later. Leave it as a, or the length in the x direction. That's fine. So for part A, so your job is to integrate from an initial value to a second value this. The 2a can come out front. You're going to have sine squared, and you're going to be left with pi x over a dx. And for part A, you have to do your limits from 4, sorry, so it's going to look like this if I was hiding that from you. So this is essentially what you're solving. And in this question, part A gives you x1's 4.95, x2 is 5.05. So you can, whatever this integral looks like in your appendix, you'll find out what it is. Put in, this is an integral calculus question. That's all that this is. And you repeat it many times for number 2. So this is really pretty easy enough. So what I can tell you is, in terms of, and I'll list it as percent. So for part A, your answer should be somewhere between 0.01 and 0.04, somewhere in that range. Percent would be 1%, that'd be 4. For part B, I'll give you the first two. This one is a lot less. Your answer should be somewhere around 0.003 and 0.009, somewhere in that range. As a percent, it would be 0.3% to 0.9% for B. So if your answers are coming out with that, that means that what you're doing is pretty much correct. So that's number 2 in this assignment.